Good afternoon to all of you. Those who were there in the pre-lunch session, I had covered the grid code situation in India. Now, this is a snapshot of our experiences from different parts, mainly from Germany and other countries. We have a manager for grid code certification based in Germany. He controls all the certification processes all over the world. And unfortunately, he couldn't make it to this session. He was originally supposed to come, Mr. Tobias. He had some issues in visa, so I'm standing in for him. I'll just run through this presentation, and then perhaps we can have a few questions. I'm working in DNVGL for last 27 years in different capacities. Most of what we do is all about independent verification or certification and little bit advisory services as well. DNVGL, just for information, somebody asked me during lunch, DNV had merged with GL. So DNV had acquired a company called Kima, which was based in Arnhem in Netherlands, and GL had acquired Gerard Hassan. So now all are in one umbrella. So our expertise in renewable energy and power systems comes from a combination of Gerard Hassan and Kima. We have put up a lot of grid codes listing, so the list is available in our website. So largely we keep constantly follow what's happening in each country, why are they doing it, and how the technology is evolving, and what are the kind of issues they are facing as part of our studies. So this is a part of the presentation. So what we do is there are three distinct phases: definition phase, verification phase, and certification phase. And we do different interventions at each of these phases. It's largely for wind, but solar we are following the same methodology again. So technical market analysis, then listing of grid codes with numbers, testing needs are determined in the definition phase. So we discuss and find out where exactly these are going to be located. If it's type approval, we are going to look at what are the characteristics, is it a new type, and what are the inputs which we're going to design, and then we define the contract, and then we verify according to those standards. And then, of course, we come to the testing phase when we need to do certain tests at site. So we have certain equipment, we have a team. Now, I'm glad to say that we have a team in Bangalore itself, so who go around to various sites and then stay for as long as they want and do the testing. We do validation of simulation model against test results. This is done through Bangalore and Germany working together. Most of the services are global in nature, so we have teams from different countries getting together. Verification according to definition phase, and certificates comply with grid codes as defined. There are some historical ways which has been quoted here from Germany. I won't be able to explain much about it, but this is the information which is given. So even Germany, the start of non-governmental certification being mandatory by law had a history. So steep rise in power production by wind turbines over a few years. From 1990 to 2005, there was a quantum jump in the production of turbines. Utilities ignored this development. So you can see a lot of parallel with India as well. They required the opposite of LVRT over years, that is to disconnect as soon as fault appears. So the traditional approach, utilities, is just to curtail. But then this could result in lost opportunities, lost energy, and perhaps some of these companies may be moving into NPAs, as we call in India, which today is an issue being talked about. Then the EU law requires reserve power from utilities. For that, they had to require LVRT within the grid code. So we understood why the grid code is required. When different players are working on one common objective, then each of them should have the rules of the game. So grid code, simply put, is only the rules of the game. And then obviously, all should be focused on one particular objective. That's where there is a problem. It should be of making available quality power to the consumer continuously, consistently, reliably, at a cost which is affordable. This is where different stakeholders have different perspectives. Then wind turbines ignored the grid code. Government required two-step certification scheme in 2009. So first was the type certificate for types of generating units, and then there was a project certificate for wind power stations. So these are plant specific. So first you do a standard testing, and then you take it to the site and do site specific testing, because there can be local grid issues which may not be consistent across. It's difficult to define a requirement. And this was required for each wind power station above 1 megawatt to be finalized prior to first connection of the wind farm. So that is very important. This project certification was required even before the first connection was accorded. But what it says is it never happened in practice 100%. Spanish royal decree requires LVRT only, but on project level for each site. So that was different. They didn't insist on a type approval as talked about by Germany, so it was only at each site. In India, the history has been the CEA requirement on LVRT was in draft and in force for many years before 2013. But wind turbines did not implement this for many years for obvious reasons. And lawsuits and discussions resulted in a stuck situation before certification was implemented to be required in India. So the first hurdle was getting the requirement in place itself. Then the solution for NVRT certification controlled by MNRE. So we have another agency, the government itself, the department. So they had a requirement, implementation of non-governmental certification within RLMM process. So I will explain what that is about. There they had identified certain requirements and they had said these standards are acceptable. So the full compliance with CEA is still not required by MNRE, only NVRT is required for the type of wind turbine. So that is as far as turbine is concerned. So this is where the complexity comes in. And the CEA draft is requiring LVRT for now PV inverters too, but yet not in force. No independent supervision if CEA requirements are implemented in the field. No project certification required in India so far. So this is a status quo, what has been mapped. We are not going into why it happened, whether it's political, commercial. There are different stakeholders sharing different perspectives. That's well accepted. What is important to understand is who are the players and what ought to be their roles. So if we can define it very clearly and make sure that one doesn't step into the other, a lot of such problems can be solved in future. First is rule makers. Rule makers' job is to write the grid codes, putting requirements into laws, which means rules setting requirements. They should have defined judging principles, verification and certification. So grid code features have to be spelled out and they need rules to define the judging principles. Then any other rules for connecting application, connection requirement agreement, and power purchase agreement, current in-feed and or rules, commissioning tests, etc. So they have to define all these rules and the rules for judgment, because they again make rules, so they make the laws for judgment. Then there should be another set of people, the judges, who should be evaluating tests by comparing the result, just to avoid conflict, that the rule maker himself doesn't judge. So the evaluating test by comparing results with the requirement, which is an assessment, stating that the requirements are met, certification. Here, maintaining independence is very important. Giving the go or stopping the plant, judgment principles can be different, but it should be clear and fair and transparent. Then we come to judgment principles. What do they consist of? There can be three components. Engineering judgment, the transparency is very low. If you just leave it to engineering, different engineers can interpret differently. So transparency is low, quality can be low or high. Experienced judges only can do it very well. Then the other one is discussing each connection singularly. That would have been ideal. So if we can take up each connection and keep discussing, but it's very time consuming, it's probably unfair for some and mostly non-transparent, because across the country there won't be consistency. So you have a verification and certification procedure. What it should have, a clear definition and specifications. It should have mostly repeatable tests. It should be equal in quality. It should be high transparency, and it should be fair and transparent if properly written down. So it should be interpreted by everybody in a similar way. So more players with more objective. Now we have more players, power producers, operators, developers, owners, investors who sell electricity, who reducing installation cost and operational cost. That is their prime objective because they want to make profit. Manufacturers of generating units, sub-suppliers, infrastructure and power plant level equipment, they provide solutions for the requirements, not directly responsible for grid code compliance, not directly responsible. End user of electricity, all of us. So all of us as consumers, we are interested in low cost of system operators and power producers' cost because we want it as economical as possible. So this brings in the conflicts which can emerge. So what could be a solution is to have a certification process. Certification means comparing, evaluating or assessing a subject with a specific evaluation criteria and stating conformity or compliance if the subject complies with the evaluated criteria. So for certification, there has to be a very clear criteria. You can't certify without a clear criteria. In our case, the subject is electrical behavior of power generating units and power plants. And evaluation criteria are grid codes and the certification procedure defining tests. The grid codes are ultimate end objective, what is to be achieved from the operator's point of view or government point of view, but certification procedure may supplement it with their own expertise on what should be done to test in order to achieve the objective. So you have a grid code for country ABC, then test standard, test results, other validation, product or project, and then there is a certification procedure. For example, most of the organizations follow a standard procedure across the world, which is monitored centrally by, again, an independent team other than the team who is performing. Then we do a site assessment to verify and sometimes do the testing and measurement and then certification according to certification procedure in combination with grid code. So we certify the equipment and we also check the grid code. Requirements taken off from the grid codes or defining according to definitions, what to test. A tailor-made test plan will cover the needs. Principles of test plan preparation is already standardized by DNV. Then scope, depending on the application, component, equipment, type or model of generating unit, projects such as a power station. Acceptance, depending on customer's wish. There are 3 options available, so which can be negotiated, agreed upon, depending on his requirement. Full acceptance by the system operator, that is grid code compliance class 1. Fulfilling defined rules and grid codes completely, which is very comprehensive. This is grid code compliance class 2, and fulfill well-defined features only, some part of it, which is list of feature definition is available. So what we are planning, since there are different viewpoints, and it's also not static, it's dynamic, it's changing all the time, and we have different players. In a country like India, to get everybody to think alike is almost impossible because we have a federal structure and we have delegated authority with the states, then we have the regulatory commission who decide the pricing, and then we have the power producers as well, and then the TSOs and the distribution companies. So there are quite a lot of players other than the generator. So in future, what we are planning from DNV is to create a grid code matrix. What we think is if all get on board, we offer sharing of know-how, translation, news, and contract-related updates, then we can constantly keep updating what should be an ideal grid code. This could be a faster solution. So DNVGL is coming with a platform called Veracity, which is on data analytics in future. So in the same platform, this can reside and it will be applicable on a web for all the parties to participate. So the key solution lies in getting opinions of all the affected stakeholders on a regular basis, deliberate on all of them, and then the government decides what should take precedence over which one, and make sure that the industry survives. At the same time, the consumer doesn't suffer. He continues to get quality power consistently, reliably at an affordable cost. So this is a objective, and that is what we do through that. So to summarize, fulfilling requirements of grid codes helps avoiding blackouts. There have been many incidents. In fact, it's there in public domain. In grid code, listing is available. Independent verification certification helps to implement grid code requirements in countries. For example, Germany, Spain, India do exist. And many players are rule makers, judges, power producers, power end users. We should have clarity between the roles of all these. Well-balanced certification system grants transparency of market and keeps qualification of players on a high level, as well as monitoring of implementation. Experience of DNVGL, more than 10 years in grid code compliance certification in a centralized manner, improved the certification procedure. Now we have standardized everything. We have learning all the time, and it can be used for India or any other country. It's publicly available. Grid code compliance certificate should be made as a two-step, in our opinion. One is the generating model type certificate, once for all the same type, and then for each power station based on the type certificates of the units produced at the site. So as I explained in the morning, that with the type approval certificate reaches a site, then we do the test and measurement and you can certify. Great cooperational services are currently developed, that GCC metrics services. So this is the proposed solution to update knowledge and perspectives on a continuous basis. So that is what I wanted to convey now. Thank you, Chairman.